देखो ये है विटवर्थ क्विक रिटर्न मैकेनिज्म. दिस इज सेकंड इन्वर्जन ऑफ सिंगल स्लाइडर क्रैंक मैकेनिज्म. सेकंड इन्वर्जन, और यहीं से शुरुआत होती है क्विक रिटर्न मैकेनिज्म्स की. विटवर्थ मैकेनिज्म. तो विटवर्थ मैकेनिज्म है क्या? जो पहला था अपना आईसी इंजन में ये ऐसा होता है. आईसी इंजन 1 2 3 4. You can see the link 1 remains fixed. लिंक 1 फिक्स्ड होती है. लिंक 2 जो होती है क्रैंक वो रोटेट करती है. लिंक 3 कनेक्टिंग रॉड थोड़ा सा रोटेट करने की कोशिश करती है और इसको ये आगे पीछे होता है. ये है फर्स्ट इन्वर्जन जिसे हम बोलते हैं आईसी इंजन. सेकंड इन्वर्जन में क्या होता है? फर्स्ट सेकंड. अब सेकंड लिंक को हम फिक्स्ड कर देते हैं जो क्रैंक हुआ करती है. क्रैंक को फिक्स्ड कर दी. अब क्रैंक को फिक्स कर दिया तो लेंथ ऑफ क्रैंक, या फिर कभी कभी दिया रहता है डिस्टेंस बिटवीन टू फिक्स्ड पॉइंट्स. अब नाउ इससे एक 1 निकलेगी और एक 3 निकल रही है. तो 1 ये और लिंक 3 ये. यू ऑब्जर्व दिस. लिंक 3 से पिस्टन और में एक पिन कनेक्शन. So in question, if you are not able to visualize which is link 3 and which is link 1, so just observe piston में सिर्फ पिन किस में लगी हुई. जिसमें पिन लगी हुई वो होगी कनेक्टिंग रॉड. जिसमें पिन नहीं लगेगी वो है अपना लिंक 1. Now in this case कनेक्टिंग रॉड, विटवर्थ कनेक्टिंग रॉड को ड्राइविंग क्रैंक भी कहा जाता है. In question it will be mentioned like the length of driving crank is this, means length of connecting rod is this. And link 1 ऐसी नहीं होती. link 1 होती है slotted. हाँ, विटवर्थ में भी slotted होती है और थोड़ी सी extended होती है. तो link 1 को या तो बोला जाएगा लेंथ ऑफ एक्सटेंडेड लिंक, मतलब यहाँ से यहाँ तक की लिंक दे रहा है, लेंथ दे रहा है, या लेंथ ऑफ स्लॉटेड लिंक, यहाँ से यहाँ तक की लेंथ दे रहा है, मतलब हमेशा यहाँ से यहाँ तक की लेंथ देगा. ये हो गया. अब नाउ क्रैंक इज फिक्स्ड. तो जब क्रैंक फिक्स्ड होती है तो ये दोनों जो है सी डबल क्रैंक मैकेनिज्म बन जाएंगे. डबल क्रैंक मैकेनिज्म बन जाएंगे. तो यू कैन ऑब्जर्व दिस पिस्टन एज वी स्टडीड इन 4 बार. इफ क्रैंक or smallest link is fixed, as crank is always the smallest link, if smallest link is fixed then we obtain double crank mechanism. So this is the main difference between Whitworth and slotted lever mechanism. Slotted lever mechanism is crank rocker. Whitworth is crank. If crank is fixed we get crank mechanism. Observe the piston. When both this link will rotate, the piston will rotate according to omega of this one and will slide on this. This piston will slide on this and will rotate according to omega of this. Omega of this, I think. Okay, so there's some confusion. I think this piston will rotate according to omega of this and will slide on this. So it may or may not be the case of Coriolis acceleration. Because on Coriolis acceleration it was like this moves here and rotates, and this link also rotates, and this piston moves. So on the same piston it was same link it was happening, but here it is happening between 2 different links. So no idea about this. So the important things are this. First, whenever the question of Whitworth mechanism appears, what you have to do? Just draw a crank, fixed crank, and draw extreme positions. These are extreme positions. This angle is alpha. sine alpha is equal to length of crank upon length of connecting rod, R upon L, length of crank upon length of connecting rod. Now for time, to cut time is this angle 180 plus 2 alpha, and return time is 180 minus 2 alpha. So QRR is equal to 180 plus 2 alpha upon 180 minus 2 alpha. So this is the QRR, quick return ratio, and alpha is equal to this upon this. So in just question, identify the length of crank, whatever be the type of figure given, just identify the crank and identify the driving crank or connecting rod. Connecting rod, there will be a pin on the piston, and that will be a connecting rod. So just identify this and you will get the quick return ratio. Now the important thing is, sometimes it asks stroke length. What is a stroke length? So I draw the piston like in this figure, like this, extended. Suppose this OA. So stroke length is equal to 2 times OA. OA must be given or should be found by some mean or maybe by geometry, but this is the correct formula of this. Stroke length, distance between extreme right and extreme left, is equal to 2 times extended part. This OC is extended part, 2 times OC. This is the Whitworth quick return mechanism. And just a sec. So you can see this question, and in a Whitworth quick return mechanism, the distance between the fixed centers is 50 mm. Means the length of crank is 50 mm. And the length of the driving crank is 75 mm. This is pin to the piston, so this is a connecting rod. So length of connecting rod or driving crank is 75 mm. The length of the slotted lever is 150 mm. This link 1, not up to here, just up to here. This is 150 mm. And there are many useless informations given, like length of connecting rod. This is not this connecting rod, it is trying to say about, and it will be specified. Length of this connecting rod is this from where tool is connected is 135 mm. Find the ratio of time of cutting stroke to the time of return stroke and effective stroke. So for time of cutting to time of return, I need this formula just. And for this formula I just need alpha. Alpha we know, crank upon driving crank. 50 upon, so sine alpha is equal to 50 upon 75. So alpha is equal to 41.80. So I can get QRR. So from here we get QRR is equal to 2.73. So this information is just useless, 135 mm. Now the second thing is, find the effective stroke. Effective stroke means stroke length, 2 times extra part, 2 times BD. अगर BD लेंथ नहीं दी है तो सिर्फ ज्योमेट्री से ही आंसर मिलेगा. This it wants to say, if BD is not given, then there is no chance you can find the question. Just a sec. Yeah. Now there is a second question. Yeah. This, the Whitworth quick return mechanism, the link length are as follows. OP, where is OP? OP, you can see pin over here. So this must be a connecting rod. OP is connecting rod, which is 300 mm, or driving crank. Right here, driving crank. OA means length of fixed link or length of crank is equal to 150 mm. If in question it is mentioned fixed length of fixed link in Whitworth, you know fixed length A fixed link is crank, so 150 mm. AR, A to R, extra part is equal to 160 mm, and RS, R to S is equal to 450 mm, which is useless. The quick return ratio of the mechanism is, you don't need anything. Quick return ratio, you need alpha is equal to 150 upon 300, alpha is equal to sin alpha is equal to, so alpha is equal to 30 degree, so 180 plus 2 times 30 upon 180 minus 2 times 30, which comes to be 2. Quick return ratio is 2. Alpha is the angle between driving crank and crank, always. So no need to draw the extreme position, just remember this. Now the thing was this: if stroke length was asked means 2 times AR, 2 times 160, 320. You can see 320 verified. So this one is verified, and this was Withworth quick return ratio. Thank you.